Hello everyone, welcome to this lesson. So in this lesson we're going to go through the first numerical method to find optimums, and that's going to be the Raphson technique, and it's going to be applied into 1D optimization. Now if you remember Raphson, we have introduced in finding roots of equations, and in this lesson I'm going to introduce how 1D optimization can actually be transformed into a root finding problem, and we can just implement the codes and the concept that we learned in previous lessons. Now let's actually begin. If you remember, this is how the optimums look like. We have a max at 0 and a min at negative 3.33. We have also explained that optimums have derivatives of zeros at these points, and also we said that these are called critical points. Now the way we're going to transform this into a root finding technique is basically if we take this function 4 minus x squared minus 0.2 x cubed and actually graph its derivative, you're going to find here we have the derivative, of course, at 0 at negative 3.33 and also 0 at 0. And basically what we can do is we can take the Raphson and we can apply it on the derivative and find the roots of the derivative function, and by finding the roots of the derivative function we in consequence find the optimums of the actual function. Now if you remember, here's how we define the Raphson technique. XR is equal to xi minus f of xi divided by the derivative. So what we're going to be doing is, since we're trying to get the roots of the derivative, basically the function that we're dealing with right now is the derivative, so f prime of xi, and the derivative of that derivative is the second derivative, of course, down here at the denominator. So f double prime x of I. So the normal roots of equation function is transformed to this function to find the optimum. So basically whatever points we find, whatever roots we find here are the x optimums of this original function. So it's a pretty simple shift and very effective. Now not only is the Raphson used to find roots of equations, but it can actually be used to find optimums as well. Okay, so now in the next lesson we're going to be just slightly tweaking the Raphson code that we have developed in the roots of equation series, and you can see from the beginning that basically we're going to be defining the function in terms of the first and second derivative, and of course since we're dealing with optimums we have to define the nature of these optimums, whether they're minimums or maximums. So we're going to have to introduce a code within the Raphson code, and we have introduced that as the second derivative test. So that's it for this lesson, and I will see you in the coding lesson. Thank you very much.